so Friday you guys were told, or you were told beforehand, to do the problems, to solve the problems you understood, and then I would come in on Monday to kind of solve the problems that you might maybe partially struggle with. Okay, so if we look at number 1, you have Pascal's triangle. So hold on, I get this out of the way. Okay, so, you know, Pascal's triangle, or our little Christmas tree. That's terrible. Okay, so this is with the exponent is 0, this is 1, this is 2, this is 3. So this is what we want, right? Because it's the third power, third exponent. So these are our terms, right? Don't count that. That's what the exponents are. So 0, 1, 2, 3. Okay, so depending how you want to solve it, you always have one more term than the power, right? So if the exponent is 3, you have one more, so 1, 2, 3, 4. Okay, you have 1, 3, 3, 1, so there's my 1, 3, 3, 1. Okay, remember, this is binomial theorem. This is your a plus b in the third power. So remember, this is going to go a to the 3, a to the 2, a to the 1, a to the 0, right? It declines. The first term, the a term, which is 3x, declines. 3, 2, 1, 0. So this becomes 3x, 3, 3x, 2, 3x, 1, and then 3x, 0, but we'll write it, but remember, everything to the 0th power is just 1. So you don't even look at that, right? Your b term is your negative y, so that you start at 0, 1, 2, 3. So the a term declines, the b term, right, increases. Decreases, increases, okay? So b to the 3, this is b to the 0, but again, it doesn't matter because that's just 1. This is b to the 1, b to the 2, b to the 3. And then you just clean it up. But I know I'm doing them all, but they just want the first term. So you don't have to calculate it on the other 3 terms. They just want the first term, so just clean this up. And so what is the first term, the expansion? 1, okay, what's 3 cubed? 3 times 3 times 3, where's my calculator? It's 27, I don't know where my calculator is, x cubed, and so this is your answer. Okay. If, say, they wanted the second term, this is 3, 3 squared is 9, this is x squared, b, so this would be 27x squared b, or bx squared. This is 3, that's 3x, this is b squared, so 9b squared x, and this is 1, 1, just b cubed. Or if you, and write 1 if you want to be precise. Okay, that's the 4th term, so you guys could try that one. Let's see. Most of you guys didn't have issues with those. I could do 5. So let's rotate the paper. So remember, I squared is equal to -1. So if you have 6 plus 2i, 8 minus 7i. Again, if you want to use box method, or if you want to write it horizontally, I'll solve the box method if that's, trying to see what you guys like. Okay, 6 plus 2i, 8 minus 7i, and just go ahead and multiply, right? The product is a cell of row times column, so 48, 16i, negative 42i, okay, negative 7, positive 2, negative 14i squared. But remember, I squared is equal to -1, right? So we can substitute. So this right here is going to turn into a positive because this is -1. So what do I have? 48, negative 42i plus 16i. It's like 26. Here's my calculator. So, okay. Negative 42 plus 16. Is that what I have? Yeah. Negative 26. Negative 26i, and then negative 14, positive, right, -1, so that's positive 14, but then you want to combine these like terms. And so 48, 14, 62, right? So you have 62 minus 26i. Let's write it again. I'm squeezing out. Okay, you only have one of these, but as far as a domain and range go, on log functions, your range is always all reals. So this is just, you could do that. You could write all reals. It can go negative infinity, positive infinity. I can remember how the I think they actually just write it as all reals on the final. Okay, what's the domain? So the domain, your restriction is inside the parentheses. So this log base 2 4x plus 18, your log is what's inside of here. It has to be greater than 0. It must be greater than 0, greater or equal to 0. Okay, so greater than 0. So here, if you solve it, 4x plus 18, that's in the way. Let's just kind of cover it. Yeah, right. Greater than 0, take the 18 over 4x, negative 18, divided by 4. So it's just a two-step inequality solving. And so you get negative 18 fourths, but if you still see it, 9 halves. And so that's your domain. X is greater than or equal to 9 halves. It can't be equal to 0 because that's the asymptote. Sketch the graph. Here you guys could just do your XY table. Okay, let me stop this video. I don't know how long it can't be that long, but I just want to, because then we'll get into these, and that way